There was another video where we were verifying right triangles, and the triangle was actually shown to us, but that's not really necessary. In this case, we're just talking about triangles, saying that they've got a side length of 9 and 12 and 15, and the question is, does that have to be a right triangle? And so we're going to do the same process, we just don't have the diagram to help us. And again, we will look at the three sides and recognize that this is the longest side, so if it is a right triangle, it would have to be the hypotenuse. So that's what we would fill in for C, and we'll call that C squared. I think that's a good starting point, even though it's kind of at the end of the equation, because we need to identify that first. That means 9 and 12 would be the legs of that right triangle. And again, I've got this written down as an equation, but really we're trying to see if that equation is really true. Okay, so now after that it's just a matter of working through the values. 9 squared is 81, 12 squared is 144, and 15 squared is 225. Okay, so I add these two things together. 81 and 144 is 225. Is that really equal to 225? Yes, it is. Since I've got two sides of the equation that are the same, that really are equal, then I can say that the Pythagorean theorem worked, which means those sides must really form a triangle that is a right triangle. Some of you might have noticed ahead of time that this was a Pythagorean triple. So if I look at my most basic triangle of 3, 4, and 5, those are just multiples of 3. Okay, so 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. And so you might have picked up on that already, and without going through all of this, been able to identify it as a right triangle. That would be another way to do it, and that's the value of understanding those Pythagorean triples. But if you didn't catch that, there's nothing wrong with doing it this way as well.